Hello and welcome to another one of these ADD videos. Today we're going to be talking about chi-squared and basically discussing the concept of it. There's two different types of chi-squared tests we're going to look at. We're going to look at the goodness of fit test here, and there's also the contingency table. They're both dealing basically with how well do our observed values resemble our expected values. Okay, we're looking basically at the same type of concept here as the proportion of populations with the z-scores, the p-hat stuff that we were doing, except for we have more than two groups usually. And what happens here is we're looking at nominal data. If you remember, nominal just means it's a variable and we're testing the frequency of that variable. And if there's more than two groups, that's when we usually use the chi-squared. Now, there's two different methods for finding that expected frequency. The first method is taking the number of people you have or observations you have times the percentage that you expect. Okay, and this is just the basic goodness of fit. And then the method two for finding expected values involves your contingency table, and the contingency table has marginal totals. And what you do is you do the row margin times the column margin for the spot we're looking at, and divide that by the total, and that'll give you the expected frequency. Okay? So once you got the expected frequency, whichever way you did it, you can calculate this chi-squared statistic. This is your test statistic. Right? So we're going to have the observed minus the expected, all squared, divided by the expected, and then you add them up for every one of those data points. Okay, so you're going to create a table, and then there's the critical statistic, the thing that you're going to use to basically determine your rejection region. And if you have just one group, or I'm sorry, if you have one population, it's the number of groups minus 1. But if you have more than one population and you're using a contingency table, you do the number of rows minus 1 times the number of columns minus 1. Okay, so more than one population versus one population. And basically this is what it's going to look like. You're going to have a rejection region always, and it's going to be dictated by your critical chi-squared value. Oops, looks like I went a little overboard there. And depending on what your chi-squared value is, you can, dictate whether it's going to be rejected or not. Do they indeed seem like they're close to your data that you expected or not? So this would be your critical value here, and based on whether your test statistic is somewhere over here, this is the one that you calculate from the formula. Actually, these are all chi-squareds, not just chi's, right? So if we're doing that and it lands on the left side, then you do not reject. And indeed, they do fit the expected ratios. And then if it, of course, lands in this area, you reject the null. In favor of the research, meaning there is a difference between the groups. So, key note here, make sure you realize that your chi-squared is only a right-tailed test. And when we're differing, we end up testing these only to the right. So your chi-squared can get really small, or it can get up to 18 or something like that, but it all depends on where your calculated one lands. All right. So this is a breakdown of what the nominal data that you should have looked at by now. If there's only one population and we're dealing with two categories only, then we use that z-score stuff that we did with the p-hats a while ago, or you can use the chi-squared stuff that we're using now, goodness of fit. Okay. If the population is greater than 2, then you have to use the chi-squared. goodness of fit. And then if we're comparing two populations and we're looking at the difference of the two populations, you do that formula that we encountered a little while ago, the z-scores. But if the population is greater than 2, or it is 2, and we're looking at more than 2 of the categories, then you have to use the contingency table. Okay? So either way, the main difference is we're going to be looking at a way to calculate your expectation, either method 1 or method 2 over here. And then you're going to calculate your test statistic, and then after that you're going to get your degrees of freedom. Look it up on the table. Ooh, I didn't talk about the table. So the degrees of freedom table, degrees of freedom go down, and then the alpha chi-squareds go across the probabilities. So based on where these degrees of freedom links up with your desired alpha, then you can get your cutoff region there, your chi-squared rejection region value. And p-values, because they're not easily calculated, usually you use a computer to get these p-values. Okay? So I hope this has clarified what chi-squared is and what it's used for. Make sure you check out the example videos on how to use this knowledge for statistical inference. Basically make a conclusion from data. Again, I hope this has cleared things up. Practice, practice, practice. Thank you and have a nice day.